tool we will look at is called Storm, and this tool was developed by a company called Backtype, which was purchased by Twitter. And so the purpose of this tool is that most of the tools we have seen so far work as batch processing, but more and more today we have real-time systems that have streaming and real-time data, and that is becoming a requirement for businesses and also for cloud computing for data analysis. So the Storm provides real-time computation. It is highly fault tolerant and robust and guarantees no data loss, and that is partially because it runs on top of that Zookeeper that we mentioned earlier, is that special high reliability platform. So it is scalable and it's mostly for real-time data. So as we mentioned, the company that developed this was acquired by Twitter, so Twitter is using this tool for their analysis. So we have the real-time data, and we need a worker to analyze this data. So we are going to add a worker. So we will reconfigure and redeploy the data which comes at real time. So we will reconfigure and redeploy, and then we will deploy the data. The reason we need this system is because scaling for real-time data is not easy. There is not a very good fault tolerance in the sense that data arrives. We don't know if some of the machines on the way might not be available, might no longer be connected to the network. So we need a reliable fault-tolerant system because networks are usually not reliable. And then coding could be a tedious and time-consuming process. So what are we trying to accomplish with this system? We want to have a guaranteed data processing. Scalability should be easy, and there needs to be good fault tolerance. So, high-level abstraction, message passing. So we want to have a system that scales very well, that is fault tolerant, message passing is easy, and also high-level abstraction. So we want something that just works out of the box. To achieve that we're using this Zookeeper platform, as I mentioned. So this Zookeeper is the platform that provides high reliability and fault tolerance. So it's going to create these zoo nodes, subnodes that are always checking for the availability. So it creates its own server. So we do have master nodes similar to the Hadoop job tracker, but the Zookeeper will do cluster coordination and make sure all the nodes that are part of it are constantly available. If they're not available, they are immediately replaced by another node. And then it will run the worker processes as a supervisor process. So that's how the Storm cluster looks like. has three concepts because it deals with the streaming data. So the first thing you will see is a stream. So let's say we have a tuple, so that's a row of some database, and we have a sequence of these tuples that keeps streaming into us one by one. And if that's the case, then that's an unbounded sequence of tuples, and that's called a stream. So there's no beginning, no end, just it's endless stream of some data type. In this case, it's a tuple. If we have one or more of these streams that come from the same source, then it's called a spout. So in this case, we have two streams coming out of that same source. And then the last concept is called a bolt. So this bolt will process the input streams and convert them into a new stream in order to implement some function. For example, it needs to do aggregation or join or do some filtering of these streams. So this is called a bolt because it looks like a lightning bolt. So it's going to take that spout and do some processing on it and create a new stream. If we have to look at the general picture of the storm, then it has a bunch of these lightning bolts that take in streams, process them, and create new streams. And that's why it's called storm, because you have a bunch of lightning storms here. So it's a network of spouts and bolts. So the spouts will generate one or more streams. The bolts will take them, do some processing, create a new stream. And it's a network of them. And that's how that system looks like overall. The way this is executed on the cluster is that the spouts and the bolts execute as a task across the cluster. So that's one task that runs, let's say, on one data node. And that's another task that runs on another data node. So they are divided into tasks. Each one runs separately somewhere on the cluster. So these bolts take one or more streams and do some processing. What kind of processing they can do? We said they can do aggregation and join, or try to do a grouping of some sort. So they can shuffle a grouping of streams. So if they have to perform some random tasks, they can shuffle the grouping. They can do hashing on a subset of the subset of the fields in these records that we have seen in tuples. So they can do hashing on that. In this way, if it's only done on a subset, it's called a field grouping. Or it can be done on all of the groups. In that case, it's called all grouping. The tasks that are performed can have an ID. So they can have a high ID or lower ID. So if we want to do a grouping by ID, we can do a global grouping. Let's see where this fits into the Hadoop system. We mentioned that most of the tools we've seen so far are for are for batch processing. So what we have here is resource management on Hadoop. There is a storage, some sort of a database. It could be NoSQL database, Hive, or HBase. And so there is data tables and index tables. And this is where the data is stored. So that there could be indexing done on this data. And next, what happens? We can have batch analysis. This is going to be batch analysis model. So some batch analysis and parallel query evaluation. And then this is the streaming model. So streaming analysis algorithms, parallel stream processing such as Storm and other tools that will do the parallel processing. And finally, whatever we are trying to discover in this data, if it's some sort of a data mining algorithm or machine learning algorithm, then the knowledge is generated from that, and then we can represent the knowledge through some visualization or another means. If it was just an SQL query and we were trying to retrieve just some results, some subset of the data, then it's just going to show the selected data. So we mentioned that this streaming analysis is becoming important because a lot of the social media data is generated in form of streams, and most of the tools are designed for batch processing. So we need some tools for streaming data. So, for example, social media streaming. Let's say Twitter. We can do a clustering on some Twitter data to see which group these particular tweets belong to. Another application this has is for high-dimensional vectors. So for data which has a lot of attributes or a lot of columns compared to the number of rows that it has. In that case, most of the regular data mining algorithms do not work very well. So if we are following some sort of a sequential algorithm on this type of data, such as k-means clustering, then it's not going to work very well. It's going to take a very long time. But with this system, it is optimized to work on that and also on streaming data. Let's say if there are tweets and we want to group them in a particular group. We can use some of their descriptions, such as URLs, phrases, and hashtags to do that. So let's say this is how an example record looks like, and we can do clustering on that. So that's an example Twitter record. So where it was created, what the user is mentioning, if it contains any tags or URLs, who is the user, and whether it has been retweeted or not. If we want to do clustering and do sequential clustering, which is the regular K means clustering. Then it's gonna create 120 clusters in 6 iterations. The computation time, 33 seconds. For time step of length 10. This is the center of the cluster. To update the center, it took 0.068 seconds. Now, okay, how do we compute the center? Well, there were that many points that we had to take the average of. So there were 47,749 points. Now, if there is almost twice as much, 76,146, then you can see the time doubles for both to compute similarity and to update the center of the cluster. So this is if we were to do clustering with the sequential method. So how do we solve this? So to solve these kind of challenges, Spark is basically the solution, because it will run much faster if we have this real-time data processing tool that is designed for working on a cluster with real-time stream of data. So the solution is this enhanced Apache Storm topology. So it's going to do sequential or parallel batch clustering algorithm. So it can either do it in a sequential way, or it can distribute it over a bunch of nodes, and each one will do parts of the clustering separately through one of these bolts that we have seen that takes the stream of data and does some processing, creates another stream. So there's going to be a separate worker process, let's say running on a separate data node that does a parallel part of the clustering in parallel, and this way the clustering will be done much faster compared to if it was done in a sequential way.